Hello, my name is Ms. Verdugo, and I'm an economics teacher here on campus. And I'm going to be walking you through our first big lesson in economics today, and that is opportunity cost and the production possibilities frontier, the first model or graph you're going to learn in this course. So opportunity cost is a term that we use in economics for a trade-off, for something you give up. Right here on the first page of this slide, it says there's no such thing as a free lunch. And what we mean by that is that everything has a cost. With opportunity cost, we're talking about the next best choice for a resource. In other words, that thing that you give up whenever you make a choice. So, for example, let's say that I gave each of you $20 and I said, here's the catch, you have to spend the $20. Can't save it, you have to spend the $20 and tell me what you did with it. Now, think in your mind, if you had 20 unexpected dollars, what would you do with it if you had to spend it today? You might say, cool, I'm gonna go to lunch with this, or maybe I'm gonna put gas in my car, or go, pick up a new shirt for school, something like that. So think of the top things you would do with this $20 and then decide in your mind, what would you actually spend it on? Now, the thing you actually spent it on, that's not your opportunity cost. Your opportunity cost is the next best thing that you gave up. Like, let's say it came down to two options. It came down to, I'm going to put gas in my car, or I'm going to get something to eat. If you decided to put gas in the car, your opportunity cost was the thing you didn't get to eat. It was the meal that you gave up. Your opportunity cost is your opportunity lost. So when we talk about the production possibilities frontier, this is a model of opportunity cost. It is a graph that shows the trade-off that we make when we choose one thing over another. Now, you're going to be doing a lot of modeling in this course, so just a general note on economic modeling in general. It is a simplified representation of a complicated thing. So we are taking a look at the economy, which can be pretty complex, and we are representing different relationships, different cause and effect relationships among different variables with a more simplified model to show how things come together. So as I mentioned, PPF is a model of choice and opportunity cost. Now, when we get into the PPF model, we have to make two general assumptions that we need to just accept here. One, the first assumption is there are only two products produced. When we're looking at these models, we're saying that this country can make product A or product B. That's it. The second assumption we make is that there is a fixed amount of resources. This society can't just go out and make resources appear out of nowhere. There's a fixed amount of resources, a finite amount of resources that they have, which is why they have to make choices. Another note I'm going to make is that you might be hearing me go back and forth between PPF and PPC. Those terms are completely interchangeable. PPF stands for Production Possibilities Frontier. PPC stands for Production Possibilities Curve, and they mean the same thing. All right, so here is our first PPF. This is a country's mix of producing cakes or cookies. So notice I have cakes on one axis and cookies on the other. Now, if we don't specify in this unit which axis to place cakes or cookies, then that means that this is the one graph where it kind of doesn't matter. You could have put cakes on the vertical axis and cookies, or sorry, cakes on the horizontal axis and cookies on the vertical axis, and that would have actually been fine. As long as you are labeling each axis, that is the most important thing. With every graph in this course, labeling is really essential. All right, so in this case, we have said that this country can produce cakes or cookies. And notice that on the curve, I have A, B, C, and D. Anything on the curve represents an efficient use of resources. So let's say this is a baking economy. This economy is using all of its baking resources very well. All the bakers are employed, all the ovens are working, they're using all their ingredients completely. So there is no waste. Now, any point that you see here on the curve, A, B, C, or D, is good. It's an efficient point of output. Now, if they are, I'm going to change my colors here. If they are on point A, it means they are specializing in cakes. It is a completely valid output choice because they're on the curve. They are efficiently using their resources. They're just saying, we're only going to make cakes and we're not going to make any cookies. If they are over here at point D, they are specializing in cookies. It means that they are putting every resource they have into cookie production and they are making 0 cakes. If they are at point B or at point C, it means that they are choosing some mix. They're making some cakes and some cookies. They are splitting up the resources. So the question is, if they are choosing to produce at point B and they decide that they are going to choose to change to point C, what is the opportunity cost of that choice? If they go from B down to point C, the opportunity cost is cakes. The cakes that they cannot produce, that is what they give up. So they gained cookies, which is cool, but they lost out on cakes. And this is a key point down here at the bottom. The reason why is because resources being used for one thing can't simultaneously be used for something else. Like we said, first assumption here is aside from the fact that we can only make 2 things, we have a finite amount of resources. So if you've taken all your butter and sugar and flour and put it into your cakes recipe, then you can't use it for cookies. If you've put them into your cookies recipe, you can't use it for cakes. They can't be used at the same time. All right, so as I mentioned, anything on the curve is good. This means no waste. Now let's talk about things that are not on the curve. Let's take a look at point G down here and at points E and F. So point G represents waste. This is underutilization of resources. So they should be producing far more cakes and more cookies than they are at point B. At point G. So this means that they might be an economy in a recession, right? And a recession means an economic downturn. You have resources that are underemployed. Maybe you have, bakers that are not working right now. You have ovens that are not optimally performing. So if you are under the curve, that is bad. That is underutilization or underuse of resources. Now, E and F, that's impossible to produce at this level today. Remember, anywhere on the curve represented using all of your resources. Every resource was employed. So if we are already maxed out, so to speak, if we are already using every single resource we have, then we can't produce beyond the production possibilities frontier. And so E and F represent some future goal, some future growth potential, but they are literally impossible today. So right now, today, the only way that this society can produce more of one product is to give up some of the other. If they want more cakes today, they've got to give up cookies and vice versa. So as I mentioned, E and F would represent future economic growth. So the way that we represent future growth on the PPC, or not necessarily future growth, I guess the accomplishment of growth. If we say, hey, this society can now produce more cakes or more cookies, that's how we draw it. We draw a new curve, shifting out and away, shifting to the right, showing us that now the society can produce more of these things. Now, the way that you achieve this as an economy, and this is a goal, right? Most economies want to grow. The way that you can achieve this kind of economic growth and an outward move of the production possibilities frontier is through more resources, higher quality resources, or new technology. So how can you gain more resources? This is one thing that's possible through international trade. Maybe the society starts trading for more flour, right? So that they can produce more cakes and cookies. They get higher quality resources. They figure out a way to make a stove that can bake twice as fast, or new technology. Now, new technology can be the form of new technology, like maybe a better quality stove or maybe a more innovative stove. But technology can refer to a lot of things. It's not just something technical. Technology can be in the form of new businesses or corporations or even trade, anything that we do that makes us more productive. And that can mean innovating. Maybe there is a baker out there who figures out a way to use resources in a better, more innovative way that allows us to produce more cakes and more cookies. But bottom line, what you want to remember there when we say, how do you achieve economic growth? New resources, better quality resources, or new technology. All right, the last thing I'll say in this lecture is there is a law that you need to be aware of called the law of increasing opportunity costs. Now, the reason the production possibilities frontier has this shape, this like bowed out shape, is because when you take resources and you start diverting them away from one good in order to produce another good, the opportunity cost of that choice actually increases. It's not really a one-to-one trade-off. And that's because resources that are used for one thing aren't ideally used for the next thing, for the other thing. So we're gonna look here. I'm gonna change the color of my tool. So this society is starting off at production point A. At production point A, they are making 10 cars. They are making, I'm on computers, my bad. They're making 0 cars and 10 computers. So they are specializing in computers. Now, let's say that they decide they would like to make a car. That's at point B. So point B, you see that now they are producing 1 car. The trade-off there is now they are not making as many computers. If you kind of look here, it looks like they gave up 1 computer. Now, if they choose to produce at point C, there's point C, they gain another car, but this time they went from only giving up 1 this time they gave, I keep flipping my cars and my computers. I apologize. They gained another car, but this time they gave up an additional computer. So to come back here, let's look down at the bottom. When they produced 1 car, they had to give up only 1 computer. They went from an output of 10 down to 9. Now, when they produced the second car, they had to give up 2 computers. They went from 9 to 7. When they produced a third car, this time, their opportunity cost increased. They used to be able to produce 7 computers, now they dropped to 4. And finally, when they get here to point E, where they're specializing in cars, now they gave up 4 computers. They're no longer giving computers. Every time they produced an additional car, they gave up more and more computers. In other words, their opportunity cost increased. And that's because as they moved, that first car that they made, they would have taken the computer manufacturing resources that were most ideally suited for cars, right? And that's what they would have used to produce that first car. So these would have been resources that are really similar to each other, kind of an easy transition. And so therefore the opportunity cost of making that initial choice wasn't that high. But as they continue to say, hey, we want to make more and more cars, they got to start using some computer resources that really aren't that ideally suited to car making, right? Maybe they're using the old antiquated factories that aren't really great for car making, I don't know, or they're using workers that really aren't that skilled in car making. And so they keep having to give up more and more. So that is why, sorry that I'm looking at what a mess that is up there, I'm sorry. But that is why we have this bowed out shape on the production possibilities frontier, and that is because of, you got to know this one, law of increasing opportunity costs. So the next thing to do is to move on to the worksheet that you've been given so that you can practice this.